The brain's universal code. How movement, language, and thought may share roots. Neuroscientists and cognitive scientists are pursuing one of the most fundamental questions in the field. How does the human brain process such a wide range of thoughts, from simple motor actions to complex abstract reasoning? A new book, The Neural Mind by George Lakoff and Srini Narayanan, proposes that the key lies in the brain's evolutionary history. The authors suggest that the same neural circuits originally evolved for physical movement have been repurposed over time to support language and higher-level cognition. Evolutionary thrifting. Why the brain reuses structures. Lakoff, a linguist specializing in cognitive science, and Narayanan, an AI researcher at Google DeepMind, argue that evolution tends to reuse existing structures rather than inventing entirely new ones. Early brains were primarily focused on motor control actions like grasping, reaching, and moving. Later developments like language and abstract thought would have leveraged these existing neural pathways. This means the same brain regions involved in physical movement are also essential for language and conceptual thinking. The authors illustrate this by pointing to how even abstract concepts are often framed in physical terms. We say we're falling in love, regimes fall from power, or ideas take hold. These metaphors aren't merely linguistic shortcuts. Lakoff and Narayanan argue they reflect the underlying way the brain structures thought. From action to abstraction, how the brain chunks reality, this idea resonates when considering how brains learn. Babies and animals develop fundamental understandings of concepts like up and down, force, and resistance, all rooted in physical experience. These concepts are then mapped onto more complex ideas through metaphor. The brain breaks down complex behaviors and language into manageable chunks, mirroring the way we physically execute actions, reaching, grasping, drinking, or construct sentences, subject-verb-object. Challenges and future research testing, these hypotheses remains difficult. A complete neuron-by-neuron map of the human brain is still decades away, making direct validation challenging. The authors propose theoretical circuit models, but concrete proof will require significant technological advancements. Despite the ambitious claims, the neural mind suffers from significant readability issues. The writing is disjointed, repetitive, and often obscures rather than clarifies. As reviewer Michael Marshall notes, the book is painful to read. However, the core ideas presented are compelling enough to warrant serious consideration, despite the poor execution. The book's central thesis, that our brains repurpose ancient motor circuits for modern thought, is a powerful argument for how little we understand about the true nature of consciousness. It's a reminder that what seems like abstract thinking may actually be a highly evolved form of embodied experience.